Welcome again to Wickerson Studios. I am starting with this number 10 file looking into the sets text section. And I'm not spending a lot of time on the text documents here. For those that like to annotate in Rhino, then I would say stay doing with that. If you start moving things and start thinking about Grasshopper as a tool for text and characters, you might be more interested in the applications of what programming in Python and C can do. I'm just going to use this on our most simplest case of actually saying, let's go ahead and find out how the concatenation can do a little something for us. And I'm using some text tags to reveal what those are. And this is a little chaotic. It's the way I kind of come at understanding things, and I'm very playful in what I create, and I encourage others to do it because we'll make some discoveries. So let's just take a look at concatenate can be a very useful tool for labeling 2D graphs in Rhino. I'm using the graph x or y, f at x or y equaling x squared. So I set up a range and domain. Keep in mind the domain is the value in the x direction, and y is what's applied through the range. And I've done a positive and negative here, and I've used a lot of panels to kind of keep track of the data and how it's being thought about as number, positive and negative, and also domains. I put it through a set of steps, and of course the scripts works if you want to make more. And there's a little bit of a randomness here, which I think is kind of fun to play with. And I was just playing around with that. If you really amp this up, it gets a little crazy, because then you can take it through a seed and have this point jump wherever it wants to. But I don't think that's necessary. It might make a little sense to you. I've got a random function in here that basically says, let's grab a list item of the points we create by running it through the expression x equaling that range and y equaling the value of x. So you end up with a graph of these points that apply to that x. And there's many ways to come at this. You can just use the nodes that are available in the maths. But I would say having an understanding of what you're then interpolating and making this curve, the length of this line is pretty interesting because I've actually wanted to pull that data out, and in pulling that data out, the length of the line should be what I wanted to bring in as my concatenation tool. So just let me make sure I did that. This will be concatenate to, okay, hang on a second, f of x. I think what I actually wanted the concatenation to be this, and there's the length of that line, and that should change drastically as I change my domain, and it does, so I get different values. So I'm just correcting this, and you'll find that the version I gave you didn't have all of this little playfulness of running in here. But the main point is I want to be able to, on that line, grab this function to say on that line p is that point xy. I wanted to know where the midpoint was, where I could put this wonderful word. I think what I did was I went in here and I put in the text calculus magic, so that appears at the midpoint of the line at the 0, 0 point. And then I've got this ability to slide the length of that line wherever I want to read that on that curve, which really runs from that point up to that point. And the length is concatenated with a text of f. And I put some spaces in here, which is so I could space it away from there with a dotted line, so I could put down the actual concatenated version of that information of what exactly is the point if I move. Now let me just make sure I have that fragment right. That fragment is not supposed to be the length. That's where I made a little bit of a mistake. I want the y component to be actually that. So there we go. When x is actually at this point, it will run straight up to where it is at y. So if we play with those numbers and move it along, not this one is the midpoint using a 3D text tag. But if I come down here and find a point, which I've had fun with a random of saying all those points I'm generating, as I seed it through, it jumps and then tells me the f at x value at the points on that curve. It's a little random and it's a little overkill. It's not really that functional for somebody working in math, but you'll get a sense of it as you play around with it. It might be confusing at first, but that's why I do live feeds in more of a lab setting when it's connected to these online open source scripts. So if x is running around this point, f at x squared is going to set it right here. And I don't have a number system really here, but you can start to estimate what that might be. I think the math's set up right. I have to check it again. I used another concatenation of length of curve, and then I added the fragment of what that length is. And I believe the length is here. So to get this right, let me put that in. I think it just changed that, and it changed it back. So the length of curve is the one that was plugged in here. I did a little swapping. But this is the one tool, and I would just go in and grab the bifocal so you can see that these are the concatenate tools and the 3D text tags of what to read. The other things I did was just grabbed a list, I think a location of a list item here, Y right here, and I grabbed an X here so I could indicate, but there's no need for a concatenation with that. Same thing with the value of this. I might want to have parametric control over where I put that on the curve. So you're learning a little bit about the concatenation tool and certainly the 3D text tag. And then all I do here is I like to extend my vectors by evaluating the curve and off within the tangent direction. So you can actually have these nice vector visualizations of a curve that continues. But the curve we're actually interested in, possibly piping, is the one of which we've brought here. And it wouldn't take much to go to the surface tool, grab yourself a pipe, and I'm sure this is going to be way too big. Pipe tool, throw it in here and see how big that jumps. Yeah, just a tad too big, I would think. Let's put in a 0.04 and see what that ends up being as a radii. And there you go. You can see the curve you've made as a polyline. And that's why I had this sense of adding more steps. So this could be, look a little more, it slows down the script, obviously, as a pipe. You have more points where you can estimate the f of x on x. I come at Grasshopper extremely mathematically from my past, and I also build things tied to a lot of work that I'm doing within the kind of sculptural world or design world where I've been for the last 30 years. So hopefully you find it interesting. I'm going to add this to the group. This isn't the one I've sent out on the drive. I may update it, and I'm just going to put down a file, save as. And because things are always in flux and I'm developing things and catching my own errors, we'll find a way to kind of plug through a few problems as we reach them, and we'll learn a lot in the process. So another short, under 7-minute video. Thanks for watching, and we'll keep going with script number 11, which in all guesses, I would say in stats, we're going to jump into probably the most complex and important section of Grasshopper, which is understanding data trees. I know we've hit it twice with the path mapper, and I got ready for this. We've used a lot of elements of it, but now we're going to break it down and probably have a multi-section longer script. Thanks very much for watching.